Good afternoon.
Good afternoon.
How you doing?
Good.
Good. Glad to hear it. Today is another glue stick kind of day, so make sure you get your glue sticks. Yes. Yesterday's we'll have a KWL. Make sure that you cut out today's notes. Watch my awesome, super awesome magic cutting skills. 1, 2, 3, cut. I did pretty good, right? That was kind of lame. You have two titles. The guided practice and the two triangles. The guided practice and the two triangles will be the first example that you will be gluing in today. The design and the weird crazy map ghost thing is going to be the second example that we're doing today. So stack those in that order, set it off to the side, and let's go ahead and get started. I still haven't updated my table of contents, so my titles are just going in my baggie for now. All right, here was yesterday's lecture. Ratios and proportions, it will have a KWL. Reminder, K stands for something I knew how to do. W stands for something that I worked hard on to learn how to do. And L is something I learned from. That means today's notes will begin on the very next page. Take a moment and get this set up for notes. Today is the 12th of January 2016, not 2015. I made that mistake yesterday.
I did it this morning.
You did that this morning. Did you do it right now?
Huh?
Oh, okay. There's my title. I really like gluing my titles down. I think they look neater than when I handwrite them.
Yeah.
Yes. You can actually read it.
And it's really big.
Yep.
I got it.
It kind of shows up. All right, let's take a moment to read over these objectives today to make sure that I'm going to stay on track and on task with what I have to provide for you today. The what objective says that I will use proportions. From yesterday, what was a proportion?
2 factors?
Look at yesterday's notes.
An equation that states two ratios are equal to each other.
There you go. That is a proportion. So you know that we're going to be doing equations. It looks like we're solving problems, so we're definitely going to be solving these equations. They're going to have to deal with something called similar polygons, so make sure I give you the definition for what a similar polygon is and what you're looking for. Let's look at the how we're going to solve these proportion problems. I will use the cross product property. What is the cross product property? From yesterday.
The product of extremes and the product of means.
Yeah, the product of extremes, the product of means. The cross product property says that those two products are equal, and that is the long version of cross multiplication. All right, let's go ahead and start off with our first topic for today. The first item is a recall. You'll need to think back to Chapter 9, Lesson 6, when we were dealing with dilations. We had a sentence that said that a dilation is a similarity transformation. Which means that it's fundamentally different than the other transformations that we were doing in that unit. Where the other transformations, the translation, the reflection, the rotation, they preserved all sorts of congruence. The similarity transformation only preserved proportion, which meant that all the sizes were different. And so size changes for proportional. So what we're going to do in this particular lesson is going to feel a lot like the dilations that you are already used to. Our first topic is going to be defining similar polygons. Remember that triangles are polygons, so we can deal with triangles too, as the title under here, the La Feria logo, says. Similar polygons are polygons that are the same shape but not the same size. In order for two polygons to be similar, they must share the following items. Yes? Yeah. You having trouble seeing? Sure. Two polygons are similar if and only if these following two conditions are true. Corresponding angles are congruent.
Miss, I have a question.
Yes, ma'am.
I can't read that. What is the chapter what? Chapter what is this?
Chapter 9. Chapter 9, lesson 6. Thank you. So corresponding angles need to be congruent. And when two polygons are similar, their corresponding sides are going to be parallel. I'm sorry, are proportional, not parallel. Okay, let's draw some diagrams and label them so that we can get a little better sense of what this means for if we need to do any proofwriting or setting up equations to solve. Before we write these, I need to give you a symbol. The symbol for similarity is going to be the tilde all by itself, and this is read as is similar to. Okay, draw your figures. Make one bigger than the other and just make sure that they look kind of sort of the same. Mine clearly are not, but we'll just pretend. I need to name these two quadrilaterals, so that means I need 8 points. Go.
C. A. L. B.
I'd love some other voices.
Q. P.
All right, there we go. There's some. Oh, I'm missing one.
R.
R. Okay. There we go. Thank you very much. We need to write that these two quadrilaterals are similar to each other. So we're going to do that by writing, drawing a little four-sided figure. So this sort of rectangle thing, name IPAC, is similar to another thing of the same shape, BQRL. Alrighty, so we have these two things true. What we need to be able to decide, though, is which ones are corresponding. Okay? When looking at the name of these figures, the first letter of its name corresponds to the first letter of the other figure's name. The second letter of one figure's name corresponds to the second letter of the other figure's name, and so on and so forth. So using that, we can write out our corresponding angles. Remember that corresponding angles are congruent, and so we'll be writing a bunch of congruence statements. So the first letter of one triangle is I, so angle I is congruent to the first letter of the other figure, so that's B. So angle I is congruent to angle B. I hear some music kind of in this area. If that's yours, it needs to be down or off, please.
It's great. It's really small.
Thank you. Yeah. He was making the microphone jump, so. Yeah. All right, the next corner is P. P is congruent to the next letter on the other figure is Q. So P right here is congruent to Q over here. Notice how this time I put two little congruent markers. The next letter of the first figure is A. It is congruent to the following letter of the other figure R. And so A is congruent to R. Can you see the last congruent statement?
Yes.
All right, it's going to be C congruent to angle L.
We have 4 lines.
Yeah, but you can see that already at 3 lines, my lines are really messy. Now the textbook and the test generators and things like that, they're going to use computers, and so their lines are always going to be perfect and beautiful, and when I draw them by hand, they're going to be ugly and messy. And so here's what I do to get around that, especially if you're like me and your drawings are going to be messy. I do 1 congruent marks, and then I write the number for however many lines you're going to go through it. So now I don't have to count or try to make them look neat. I'm just going to put 1 line and then write the number 4. Especially helpful when I have a really small space that I'm working in. Okay? All right, so we have our corresponding angles. The next thing for us to do is figure out our corresponding sides. But more than this, we have to make sure that we write them in a proportion, which means we're going to be writing a long series of fractions that are all equal to each other. Our first choice to figure out which side is corresponding to which other side. Looking at the figure on the left, the first letter in its name is an I, the next letter in its name is P. So this side IP is going to correspond to the first and second letters of the name of the other figure, BQ. Those sides correspond. You can even look at the angles to see how many little congruent marks are there, and that can also help you see which sides are congruent. The next one is going to be P and A are the next 2 letters in the name of the first figure. And so the next 2 letters of the name of the second figure, are Q and R. So on and so forth. The next side is CA. The next side is RL. And then the last side is CI. And over here will be LB. So we're going to go ahead and write that. Now, it doesn't matter which one you choose to be in the numerator for the first one, but once you've made a choice, you have to keep that choice throughout the rest of the problem. I'm going to put the figure on the left's information along all the numerators. So here's one side, here's the other side, here's the third side, there's the fourth side. In the same order, in terms of corresponding sides, I'm going to put the information on the figure to the right in the denominators. I started here with IP, so here I must start with BQ. And I'm done. Questions? Pretty straightforward, yes? The last comment for this page, has a recall in it. The last thought for this page says this: the ratio of side lengths of similar polygons has a special name, and that special name is the scale factor. If you like. Thank you. Now, where have we heard this word scale factor before? Where have we heard this scale factor before? It's a Yeah, when we were dealing with dilations, the scale factor in dilations was telling us the number we had to multiply to one figure in order to generate the other figure. We were creating, when we did dilations, we were creating a bunch of similar polygons. I'm out of room on this page. Follow me to the next page and glue in your first example, which is the guided practice and 2 triangles.
Do I need more space?
Yeah, you're going to need at least half a page. If you write small, you could fit it. You don't have to do the T-bar on this one. We're going to write all over the page. If you did, it's okay. You didn't do anything wrong. Someone with a nice big voice, read for us the guided practice.
Find the value of each variable if triangle JLM is congruent.
Similar.
Is similar to triangle QST.
Beautiful. So we know these are similar triangles, which means we know that their angles are?
Similar.
Their corresponding angles are
Congruent.
congruent, and their corresponding sides are? Go back to the notes we just wrote.
Scale factor. Corresponding.
Proportional. Corresponding angles are congruent. Corresponding sides are proportional. Which means we need to first identify which side corresponds to which side. So again, I'm going with some colored highlighters. The first 2 letters of this figure's name are J and L. So that side is going to correspond with the first 2 letters of this other figure's name, Q and S. The next 2 letters in this first figure's name is LM, and so that side is going to correspond with the next 2 letters of this figure's name, S and T. And my uncolored sides are corresponding as well. This allows me to write all the sides as proportions. JL is to QS, as LM is to ST, as MJ is to TQ. And that's using the definition from those similar polygons from the previous page. So far, so good?
Yes, I'm just trying to recheck it.
Okay. We're doing all right. We've got a little over 20 minutes left. Now that we have this, we want to use this information to find the value of y. The y information is found with this side. So I'm required to use the information of the side JL, which forces me to use this scale factor, the ratio of those sides, this one here, JL over QS. That ratio is equal to either one of these other 2 scale factors, and the short answer to the question, well, which one do I pick, is it doesn't matter, just pick one. But the long answer is pick the one that's the most helpful. Your goal is to find the value of y, and so if you select LM, you're putting in a non-y variable. You're not wrong, but it might make things more complicated. And the whole goal is to make it as simple as possible. So this one, while the right choice, isn't the easiest choice. So select the other scale factor instead. MJ and TQ. Now that I have those sides written down and I know what my proportion is going to look like, I can just grab the information and substitute. JL is 3y minus 2. QS is 5. Thank you. MJ is 4. TQ is 2. I have it set up as a proportion. What can I use to help me solve proportions?
Cross multiplying.
Cross multiply, whose formal name is? The cross product property. So cross multiplication, yes, but I'm going to start calling it the cross product property to get you used to that formal name. Cross product property says multiply the extremes. Now notice how I'm not going to actually do the multiplication right now. I'm just going to write down that I need to get it done. This is so I don't have to use any of my brain power right now on trying to calculate numbers. I'm using it solely to make sure that I have performed the cross product property correctly and that I've written down all my numbers correctly. Now I can multiply. 2 times 3y is
6.
And 2 times 2 is
4.
5 times 4 is
20.
simple equation to solve. I'm going to go ahead and get rid of this subtraction of 4. I do that by adding 4, which gives me 6y equals 24. Need to get rid of the multiplication by 6, and so y equals 4. I'm just going to take my yellow highlighter to put kind of work lines between each of my steps to make it easier to follow. Questions on how this happened? Seems pretty simple and straightforward? Awesome, because one of your first grades in this class today, this semester, is going to be notebook check number 1. And what you're being asked to do on notebook check number 1 is to use this exact same process to find the value of x. You have the rest of the space on your paper? No, from this one. Okay, so use this one. Here's your technique. Set it up, find the value of x. Sometime between now and when you come back to class tomorrow, I will want to see this notebook check. What I would love to see is tomorrow you to walk in, you're going to hand me the notebook, then sit down to take your test. While you're testing, I'll flip through your notebooks and make sure that you've done all the work. So please show out all of your steps. Okay? On to the next page. Oh no, let's figure it out after our last example. We're almost done. This is the final topic for today. This topic is called the perimeter of similar polygons theorem. Since this is a theorem, you can probably expect to have to prove it with a formal 2-column proof sometime between now and the end of the year. So as we're writing down the if-then statement, be thinking to yourself, what information do I have to have in my setup? And what information could I need in order to show that the then part of the statement, the conclusion of my conditional statement, is in fact true? Here's what the theorem says. If 2 polygons are similar, then their perimeters are proportional to their scale factors. Draw two triangles, one larger than the other, and then be prepared to give me 6 letters from 6 different people. All right, letters go.
J.
A.
C.
Q.
P.
You already said it.
I. Let's go.
U.
You already gave me a letter.
T.
T. Jackie it.
No, cat.
Jackie T.
Jackie T.
Jackie and then T.
Jackie T. All right. The first thing we need to know is that these polygons are similar. So we're going to write over here that triangle JAT is similar to triangle CQI. The next thing is we're looking at their perimeters and their scale factors, which means we're looking at side information, and it says that they're proportional, which means I'm going to have one ratio handling all of the perimeters of our triangles, and that's going to be equal to the scale factor between my triangles. Remember that scale factor is the ratio between triangles. All right, let's find the perimeter first. Let's see, JT plus JA plus AT, CI plus CQ plus QI. All right, we've got all 3 sides. Now for the scale factor, it doesn't matter which of the 3 side pairs you use, but please make sure that they are corresponding. So once again, back to my highlighting so that I can see which ones correspond. JA are the first 2 letters of this triangle, and so that corresponds with CQ, the first 2 letters of the other triangle's name. And so I can use that as my scale factor. Please notice that the first figure's information is all in the numerators, and the second figure's information is all in the denominators. It's important that that matches. Numerator to numerator is all one figure. Denominator to denominator is all the same figure. Okay? Don't mix them up. Don't put one figure's information in a numerator and that same figure's other information in a denominator. That won't work. Okay? Go ahead and glue in the final example. I'm going to go ahead and glue it in way onto the side of my paper. Right. Someone with a big voice, please read.
Oh, design. On the blueprint of the apartment shown, the balcony measures 1 inch wide by 1.75 inches long. If the actual length of the balcony is 7 feet, what is the perimeter of the balcony?
All right. So this is the balcony. And in this blueprint, the blueprint is a drawing of a building, shows you where everything is, shows you where doors are, it shows you where windows are, shows you where big pieces of furniture are, like this is maybe either a bookshelf or a table or a TV, I'm not sure which. There's a stove here, I think, and a sink and maybe a counter. And here, this looks like it could be the bathroom because this thing kind of looks like a toilet right there. And a very, very small shower stall and a sink. And this is probably the bedroom, because that thing looks like a big bed, yeah?
Yes.
And then double doors, and so this must be the balcony. And here, physically on the drawing, this wall is physically 1 inch long, and this side is physically 1.75 inches. However, when the contractor goes out to actually build this thing in real life, he is not going to make this balcony 1 inch by 1.75 inches. He's going to make it something by 7 feet. So this is a dilation. He starts with a small drawing and he scales it up to make the big real life structure. He's making use of similar polygons. So using just this information, we have to figure out what the perimeter of the balcony is. This idea of the perimeter of similar polygons can come to our rescue, because we can set up our proportion between perimeter and scale factor. The perimeter of the scale drawing, the blueprint, is going to be 1 plus 1.75 plus 1 plus 1.75. I have no idea what that number is right now, and I'm not going to worry about it. I'm just writing, add all the sides together. The perimeter of the balcony has one side information that's missing. I don't know what this is. So I'm going to use the variable W to represent that missing width. And so the perimeter of the real life balcony is the width plus 7 plus the width plus 7. And that equals to my scale factor. I've only got one side where I have both pieces of information. It didn't matter. I could have used the other side, this W to 1. But that could make things more complicated, because now we're introducing another variable where here it's all numbers. So I'm going to use the one that's all numbers just to keep things a little more simple. This is one equation that you can write with. Note this isn't the only solution to it, but this is one way that it'll get there for you. Right, I'm going to use my favorite pocket calculator. I'm first going to turn down the brightness of it so that it picks up okay. There we go. I'm going to ignore my Facebook Messenger that my friend sent me a photo of something. I don't know what friend, sorry. I'll look at it later. Pull up my pocket calculator. I'm going to move her face. And now I'm going to start typing this stuff. Yeah, my Facebook Messenger shows her face. So I'm moving her face out of the way. 1 plus 1 plus 1.75 plus 1 plus 1.75. And the perimeter of the physical drawing in the blueprint is 5.5 inches. The perimeter of the actual construction is 2 times whatever the width is plus 14. I'm not doing anything yet to the scale factor. All right, now that I've got my proportion easy to look at, I'm going to go ahead and use that cross product property to start my multiplications. And once more, I'm going back to my pocket calculator because I have no idea what 5.5 times 7 is. Pocket calculator says that it is 38.5. Cross product property asks me also to multiply the means together. And again, I'm not going to think about this one. It's too hard for me to do that right now. So I'm just going to write down that I need to multiply them. Now I can do this distribution. It's easy for me to see what I need to do. 1.75 times 2 is 3.5. 14 times 1.75 is 24.5. Make sense what we're doing? Making sense? Yes? Somewhat?
Yes.
I did some distribution right here. That's how I got these. I want to get rid of this addition by 24 because it's in the way, and when solving equations, it's always a good idea to get rid of addition subtraction first. So 38.5 minus 24.5 leaves me with 14. And now I'm going to get rid of that 3.5 that I am multiplying by using division. 14 divided by 3.5 is 4. Just going to go through and separate my steps a little bit, make it easier to see. I'm done, right? Did I answer the question?
Yeah.
What was the question?
What is the perimeter of the balcony?
Did I find the perimeter?
No.
Nope, I just found the width of it.
And
So
then now you need to look for the.
now I need to go find the perimeter. Remember that the perimeter is the width plus the length plus the width plus the length. What's that? 4 plus 7 plus 4 plus 7.
11.
4 plus 7 is 11. I have 11 twice.
And then they both equal 22.
And so 11 plus 11 is 22. Any general questions about anything that we did today?
Is that what we're gonna be doing for
Yeah.
for a while?
For a little bit. All right, thank you very much.